Welcome to day 3 at 18:30. The next talk is about Haxe, a web programming language, because it targets web servers and clients. The hacking in the subtitle refers to creating, not breaking. Please welcome from France, Nicolas Cannasse.
Guten Tag. So I will talk to you about this project. It's not longer a project, it's more like working software. I've been working on for a bit more than 2 years, and I have some interest about programming language for a long time, and actually I wrote several compilers before doing this one. And finally I come up with Haxe, and I hope you will enjoy it. So I will just introduce a bit what Haxe is about. So this is pretty much what is the web today. So you pretty much, I think you know already what about this, but I will just go quickly. So you have client-side and server-side. On the client side, you have a web browser, and you have several display technologies that are being used to display websites. You have HTML, CSS, and Flash. So that's the three main things that you are using to display content for the user on the web browser. And for each of the technology, you have a programming language that can be used to manipulate this display and to just make it interactive. So for HTML and CSS, you can use JavaScript with these different implementations, but basically it's the same language. And for Flash, you have ActionScript, which is a pretty not so much known programming language that is used to just write Flash content and make it interactive. And on the server side, you have several different technology because you have a lot of choice. You can't really choose what you want to install on the client side, but on the server side, you can install anything on the server, and that's a good thing. So you have a lot of different programming language you can use on the server side: PHP, Java, Ruby, C#, etc. And well, there's a lot of different technologies there. And the server, you access some kind of resources for doing websites like a database and file system. So basically what the web is today. And it's quite a bit complicated because basically if you are trying to make a website with some HTML, Flash, and the server side, you have at least maybe 3 programming languages to know, to learn, and to master. And you have to talk between all these components. So what Haxe is proposing is to do that. Just forget about everything and just replace everything with Haxe, and it will be fine. I mean, that's the idea. But it's not a thing you have to do. I mean, it's just a possibility you have. If you don't want to use Haxe on the server side, you don't have to be assured that you can use it only on the client side if you want, or only on the server side if you want. But you have additional APIs that you can use if you want to use on both sides, and it makes things more easy. So during this talk, I will try to answer 3 questions. The first one is, what are the features of Haxe? What it's doing? The second question, which is an important one, is why to write a new programming language? Because I'm often asked this question. People wonder why to write a programming language. Why not to use instead this programming language that I know and that I could use? Just please do something about it. But I will try to answer this question and, about writing a new programming language. And this is kind of corollary question, but how is Haxe different from another programming language? This is also important because if it's the same as another programming language, then there's no reason to write a new programming language. So I will try to answer these 3 questions, and hopefully I will try to answer. I will be able to answer these 3 questions in this talk. So Haxe is a new programming language. That's something you need to know. This is not something that's been done before, I think. And it brings its own set of API syntax, and with it, basically, it looks pretty much the same as Java, if you don't know Java, from like a beginner point of view. And it has a standard library. So all things containing array, list, hash tables, math function, all the things about computing that is not really bound to any specific platform is in the standard library. And you have a specific APIs because Haxe targets several platforms. There is 3 platforms supported right now. Several could be added in the future without any problem. There is a JavaScript platform. So basically, you have the standard library, and then for JavaScript, you have specific APIs for accessing the DOM objects, for manipulating HTML content. Then you have the Flash platform, with APIs for doing sound, video, and all the things you can do with Flash. And then you have a third platform, it's called a Nico VM, which is a virtual machine, which have also like specific APIs for accessing file system, databases, and a lot of different things. So we'll have a look into these three platforms. But before that, I want to show you some work I'm doing. I built a company with some of my friends, and we are doing some kind of website, a games website. And I want to show you what is the results of Haxe in action, actually how it works when it's running. If I can get my mouse. Oh, my mouse doesn't want to move anymore. I will try. This is Windows, right? So just don't blame me, not me. So, okay, I will try just this. Usually it works this way, you know, and just. I mean, when you're at it, you don't have any other way to do that. So, sorry, thank you for your patience. Okay, so it's. And just restart. Hello. Okay, and we are back with the mouse. Wow. Okay, so I just running a local version of the website on this machine, so I'll show you what it looks like. So basically, you have this website, you can subscribe, and it's just some kind of game website we are doing in France. So it's entering in French, sorry. So you can buy this kind of small creature, which called dinos. It's a little bit like Pokemon, you know. So they have all different characteristics and things like that. And then once you buy one, you can fight with them. So this is one I have. You have some kind of level, like life points and experience. So here you can see you have a lot of different components. So you have basically one file that is entirely generated by the server side. And then you have like some JavaScript tooltips, and here some Flash content that you use to display the map. And for example, I can move on the map with this. So this is an interactive map in Flash. And when I move on the map, it starts a fight. So you can see the fight between the monsters and stuff like that. Get away. And the fight results. So basically, the fight is entirely calculated on the server side, and only the result of the fight that it need to display is sent on the client. And the fight is not interactive; it's already executed on the server. So, oh, and so at the end of the fight, when you kill all the monsters, I'm almost done. Oh, that's done. Okay. You can see there's these things popping up. Thank you. So there is these things popping up there. And okay, this is Flash. Okay, and this is HTML. So basically, we are using JavaScript to just pop these things on the form under Flash, and it's triggered by the end of the fight in Flash. So, well, I mean, this is not really something new. I mean, you could do it with current technology, but the fact that we do it with Haxe is so much easier to do that. I mean, you don't have any really to care about spending time doing it. So this was just a small show of things that you can do with Haxe. And we have already like several tens of thousands of users on this website, so it's scaled pretty well as well. So let's have a look at the different platforms supported by Haxe. So Haxe first, let's have a look at JavaScript platform. So Haxe compiles to JavaScript. It means that you have all this set of classes, and it generates all into one single .javascript file that can be included in your website. So it's cloud-based, so like Java, if you know Java. So The good thing is that when you compile one class, it will compile all its dependencies together and link them together into one single .js file. So usually when you are doing JavaScript, if you are using some framework, maybe you are using only a few classes of the framework, but you need to include the whole framework because it's difficult to track all the dependencies. And for this, the compiler will do it for you and just only generate JavaScript that contains only the class that you need to use, actually. So, and then we have some cross-browser standard APIs for XML, HTTP request, all these kind of things that usually takes a little quirks between the browsers. You can do like, it's part of the standard library in X, so you can do it whatever the browser you are running on. So let's have a quick look at some example in JavaScript done with Haxe. I'm putting the idea, I'm using some kind of called Flash develop to just develop the, to write X content. So this is Product Manager. So you have just this JavaScript target. So here you have like output. So you say we generated code.javascript. This is a JavaScript project. It has a main class, and we will call main function. And here is the main class. So is it? Can you see well, or maybe I should grow up a bit? Okay, maybe this is better. Okay, so what we're doing is just iterating from 0 to 3 because it's 4 exclude, and we are getting the get element. You are using the gs.lib get element by ID method, which enable you to capture some element from the HTML. And we are changing the inner HTML property, which is saying I'm a sharp and the number that we are iterating. So we have this HTML. So you have this x0, 1, 2, and 3 that they are just reference from this code. And so we will just iterate into this 4 div. This is a script that includes our source code. And we just inject some HTML inside, change the content of the HTML. So when we start, you can see I'm 0, 1, 2, 3. So that's basically a way to manipulate HTML. So the good thing about this is that we can also manipulate style. So let's have a look at this. So here I'm setting the style.background to red and the style.display to inline. And it doesn't look, but actually the language is completely typed. So if I'm writing these kind of things, I have these tooltips that show me all the available properties for the. So if I want to say, for change the color, for example, of the text of the style CSS, I can choose red. If I'm putting other things, I'm putting blah blah blah, blah blah blah, and I'm trying to compile it. It just says an error that gs.style has no font, blah blah blah. So I can bypass that, but I will not do it now. So I will put the text in blue, the background in red, and the display as in line. So, and then I will start my web pages. I get that this display is in line, the background is red, and the color text is blue, so it works. So let's have a look a bit at the generated JavaScript code. So this is basically what is generated by the X compiler. So I told you generate one single big JavaScript file. So it contains a few classes. So you have the std classes, you have and here is our code. So you can see our code is not so much complicated. It's pretty much generate what you write. It doesn't add an additional layer on top of it. It just had 1 or 2 class more for the standard library. But basically, it generates the same of what you in JavaScript of what you have been writing in Haxe. So that's a nice thing to know. It's not, it doesn't cost anything in terms of performance because it generates pretty much the same code. And we can add a on-click event, for example, here. So every time we click on the element, we trace hiding, and we put the display into none, so it will hide the element. So if I start, and try to put bigger. Okay, so if I click, it will just hide the element. The trace goes into the HTML, which call this div here there. If you don't specify it, you just pop up a window, but we don't want to pop up a window, so you just define this div there with an ID, and all the trace we are doing in the code will go there. So here you can hide all the things, and it's pretty interactive, isn't it? So One of the other things we can do is that, for example, if we just iterate instead of iterating from 0 to 4, we iterate from 0 to 5, when we run the example, it looks like it's working, but actually, if you could look at the errors, you will get an error that ELT has no properties because you're accessing some kind of null object because it doesn't exist. And it gives you an error number, which is in the JavaScript file, line 663. And you don't really want to have to look in the JavaScript file to know which line is it and then to go back to the Xcode because it's pretty tricky to do. So what you want to do is to know in which at which place it occurs in the Xcode you are writing. So what you can do is just you can turn debug mode on into the project properties, and then you start. You just compile again, and then if I'm refreshing, I get this nice pop-up that shows the exception, and it says in which method it's been called. And it shows you the whole stack trace. So if it's called into some methods, it will display all the stack trace that has been called and that at the place that the error has occurred. So it's pretty neat to have this kind of stack trace in JavaScript. So let's look at how it's done. If you look at the JavaScript generated when you are in debug mode, you will see that there is this $s.push and $s.pop, which is basically, it's not really optimized. It could be, some could be removed, but basically what it's doing is just maintaining a stack trace at every point of the program execution. So it's loading down a bit JavaScript code, but this is some debug thing, so you don't care. And when you are making a release, you don't need to. You can just remove the debug code, and it will just generate pure JavaScript code. So that's basically what X is doing with JavaScript. So you have all these possibilities to just write JavaScript components with Haxe. So we move on to Flash. So the problem with Flash is that traditionally Flash is seen as a proprietary technology. You need to buy the Flash IDE to develop Flash content, or you can get some tools to do that. The FLA format that is used by the Flash IDE is closed source, but the Swift file format that is run by the Flash player has been reverse engineered. I've been doing that for some years now. And basically what Haxe is doing is just create a Swift file for you. It just compile to Swift file, to Swift bytecode. And you can just, and it's an open source compiler, so you just can develop any kind of Flash content with Haxe without just getting any kind of tools from Adobe. And it works on, of course, on Windows, Mac, and Linux, and all kind of other like operating systems. So it has some more language features compared to ActionScript, like typed arrays and a lot of things, and offer better performances in terms of compile time and runtime. So let's have a look at what we can do with the Haxe in Flash. So I see the small example. So it's pretty much, it looks like the same compared to JavaScript. So you have the same, we have the main classes. But what it changed is that we have a project there, and this project say, okay, I want to generate to Flash, and this is code.swift, and we call it in the main function. And here you have this movie clip. A movie clip we are creating there, it just some kind of display content. So it's just something to display something, some kind of drawing some context. And then we are centering it on the stage. And then for each frame, we execute the loop function. A frame is just something that is a term of Flash, which means that the main loop. Okay. So when you enter in the loop, what we are doing is just setting a random color, and then you are drawing to a line to a random point. So basically, we are doing some kind of random thing. So we compile and we start. So what we have is a Flash content that draw random lines. I mean, that's not really something very impressive. It looks ugly, man, I would say. And but you can add some kind of nice effects. For example, let's add some rotation. So it looks a bit, I mean, more psychedelic, maybe. And you can have a kind of, this is a time variable that I will just increment, and then I will change the scale also, depending on the cosinus of the time. So basically scale is when you are at 100, it's maximum normal scale, and you can just scale. So when you have the character, oh, you know, I'm a little bit drunk, like it's just a strange feeling, you know. Okay, does it hurt? Yeah, okay, I will stop. So this kind of thing you can do with Flash, but I will show you more we can do with Flash, because this is, I mean, this is pretty basic thing. And I wrote this another sample. So basically I took the same source as the things I've been doing there, and I added some additional bitmaps. This comes in Flash 8, and this is a way to store some, like the graphics, the vector graphics, you can store it to some bitmap, and then you can apply some filters to it. So for example, you have this color matrix filter, which is a way to change the colors, and you have this blur filter, which adds some blurring to the, like, apply some blur filter at runtime. So I will change it, I will use main2 instead of main, and compile. So you can see it's fast to compile. And then when I run, it's just, well, it looks a little better than before, right? So you have all this blurring occurring, and the pictures are fading, and so this is kind of things you can do with Haxe and Flash. And this is pure code. I mean, it looks like something like 1 hour, less than 1 hour to write that, and just you can experiment with all of kind of graphic things if you're interested in this kind of thing. So that's all for Flash right now. Let's back to the slides. And then let's have a look at the third platform that Haxe can target. It's called the Nico VM. So it's a Nico virtual machine. It is a more small and lightweight virtual machine that can run some kind of bytecode. It has just-in-time compilation also. It's designed to be lightweight, so less memory usage, and it runs pretty fast. So basically what Haxe is doing is compiling to .n bytecode, which is a bytecode for virtual machine. It's compiling, again, all the classes together into one single .n file that you can deploy on your server. And it has a lot of system APIs, so databases, file systems, sockets. So basically what you are doing for the website I showed you before, we are using Nico VM on the server side. We are using a mod Nico for Apache web server, which is 25,000 PHP. So that's pretty good news in terms of performances. And that can, of course, it's 25 faster if you are using like computing, if you are just doing some calculus or algorithms. If you are just doing database requests, all the speed is taken by the database, so it's not only it's not the code source itself, but it's sometimes faster than 20 times, sometimes a little bit slower, but it's around 20 times faster than PHP. So let's have a look at something you can do with Nico. So okay, same here, I have a project which is Nico. We are compiling to index.n, which is the default file. So here we have main.hx. So we'll just make it a bit bigger. So here we have some kind of anonymous object declaration. When we say, okay, Nicolas, age, city. So this is some kind of object. And then we will just go to the main function. So we get the content of mypage.html, which is on the local file system. And we will format it with the information, and then we'll print it on the output. So format will just iterate on all the fields of these objects, and it will just replace double dots with a key double dot by the value. So if you look at my page here, we have hello name, I know you are age and you are living in city. So that basically we will replace this kind of template. It's very a small sample. So this kind of template, and we will replace the template with the actual runtime information you get from code there, which could be from any kind of databases. So it's not. So I compile, and if I run, it will just make enable to connect because we are connecting on local host on port 2000. And I will just run as a small. This is a small web server which is written in Nico, in Haxe somehow. And so you just run start the server, and just you can run it also on Flash on Apache web server. But for this example, I choose to just run it on this development server. So here you can see that it's replacing the variables in the template system. So I mean, that's how you will do for websites. But websites, you have also like parameters in the URL. So let's trace what is the value of the parameters. So here you see it's like the empty hash. And if I'm adding some parameters there, like hello equal world and by equal by, then you can see that you get an hash table with which is filled with all the parameters that are in the URL. And also, if I'm doing, I can trace also the URI, which is the resource which is actually accessed on the server. So here we're accessing to slash, so we'll try slash. But if we access to blah, 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 so it's like directory, we get the URI, which will be blah, blah, blah. So basically, that's how you will write a website with Haxe. You will just capture this information, the URI and the parameters, and you will split it and use it all you want to dispatch to a controller or something you want to generate web pages. So I mean, that's pretty low level. You don't have any kind of big frameworks, you know, it's not Rails. But you can do pretty much what you want with it, and it's quite simple to use. We have already some libraries for helping with that kind of things, and just helping you to structure a website with this, but you don't have to use it. So let's have a look at some other features of a web service writing in Haxe. Is that if I'm doing that, I will just get older, okay? But if I start the web page, what's wrong? Okay, and if I reload the web page, it doesn't change my age, okay? This is why, because every time you just make a request to the web server, the bytecode is reloaded, and it's just everything gets initialized again. So that's normal application. It's pretty much normal for all the websites. But what if I want to, for example, to get this information in some kind of big XML, and I want to cache it somehow? What I can do is just, I can call this method, which is called cache module. And you say, okay, next time we will, next time a request on the same .n file will occur, instead of just reloading the bytecode, just call this main function instead. Just call this function. So I'm passing it there in a function, which is the main function there. And they, okay, next time use this entry point to initialize, to call my website. So basically, if I'm doing that and I'm refreshing the web page, you can see that the edge is increasing. And if usually when I modify the .n website, the .n file, it will just reload on the next time. But this is not working with the Neko dev server, so I will just restart the server. And if I restart the server and I access it again, of course the cache is cleared, so we start restarting from 28. So with kind of things, you can pretty much catch any kind of static data you have, and just be able to have one website with a lot of some kind of shared memory, which is all the statics. And you can make some kind of persistency of it. And of course, if you want to modify the data, it's better to store it into the database, because you are sure that if your server crash or something, you can just get it back. But for a lot of data that is not modified so much, or that is just statistics, you know, you can just store it into memory. So it makes a lot of sense. And it really speeds things really a lot, because the whole bytecode is into memory already, and you don't have to initialize all the classes. So just, you get a lot of speed out of it. So, but this is not only you don't have ready to use some kind of web server to develop with Neko, because it's also a virtual machine, so you can use it from command line as well. So if I go to browse and then what is X? This is it, and then okay. And then I can call Neko. So this is like a command line for starting the virtual machine, and I'm just using index.n, which is the file that I boot. And you can see it generating the code and printing it on the standard output. So basically, what you can do is just you can write a web server, and then you can also like call it from command line with any kind of things you want. So, for example, if I trace the URI there, I compile. So here is slash, but I can call it with blah, blah, blah. So this is the first parameter. This is like kind of, and you see that it will execute a blah, blah, blah. It's pretty much the same. If I'm passing the parameters, well, it will just pass the URL as well. So that's basically how it works. So we're pretty much done into just doing some introduction of the different platforms supported by Haxe. But what you can do is basically when you are just writing code, if you are not using any specify API, which is a file system or flash display or JavaScript access, you can write code that compiles the same on all platforms supported by Haxe. But that's a possibility that you can use where it matters, because you don't really want to write cross-platform code all the time. I mean, if you are doing some video, it's obviously you will do it in Flash. You can do it in JavaScript, and you can do it on the server side. It doesn't really make sense. If you are doing some kind of database access, you can do it directly in Flash. It will be not very good. So where it matters, for example, is when you have a big form and you want to check it, to check that the input is correct. For example, you want to check that the username is not so much long, that the phone number is well structured, that the email address is correct also. You want first to do maybe some checks in JavaScript on the client side to ensure that everything works well. And then you want to do some checks on the server side in case the user disables JavaScript or bypass it in some ways. Before inserting the data into the database. So basically, when you are doing just form validation, and it can be pretty complex in some cases, you are doing 2 times the checks, 1 time on the client side and 1 time on the server side. And if you are using 2 different programming languages, for example, JavaScript and PHP, you will have to write the same test twice, and to make sure that both are actually doing the same checks, because if the user first checks things and it doesn't work, and well, it gets complicated from there. So when you do it, in Haxe, you will just put all your code from validation in some class, and you will just compile it once for the JavaScript side and once for the server side, and you will use the same code and the same logic on both sides. So it's pretty powerful this way. So what you can do also is sometimes that you want to, for example, let's think that you have some algorithm that builds some kind of data into memory. Then you want to display it. And the notion of display can vary from platforms. For example, if you are in Flash, displaying might be just put it on the screen. And if you are on the server side or from the command line, displaying might mean to just save it as a PNG file on the disk or something. So if you want to have this kind of different behavior depending on the platform, you can use some kind of conditional compilation that will say, okay, if I'm in Flash, I will do it this way. If I'm on Nico, I will do it that way. So that's basically what Haxe ASM is doing. So this is some tools, some library has been writing. This is the Flash 9 assembler library. So it just enables you to just code Flash 9 assembler, which is pretty cool. But I wanted to use it on the Flash side because I wanted to be able to generate dynamically code on the client side and be able to optimize some 3D stuff or stuff like that. And I want also to be able to use it on the server side because I want to maybe just compile dynamically to generate some Swift file, or I want to just run it on the command line and then be able to store the Swift that's been generated this way with this Flash assembler library and reuse it later. So what I did was just to write all the content of the code, which is abstract. It means it doesn't use any specific platform library. So for example, let's have a look. This is some kind of declaration. There is all the declarations there for what is method, field, class definition, and different opcodes, which are also opcodes for Flash 9 bytecode. Okay, so all the definitions are common on both sides on all the platforms. And then there is this writer class that just turns this bytecode into bytes actually. So it just take an output and then it writes bytes to it, depending on the Swift format. And And of course, the output depends, and this is there where we are using conditional compilation. Here we have just, if we are on Neko platform, what is an output is defined this way. And if we are on Flashline platforms, then an output is defined this way. So this is a kind of small way to just write cross-platform code by defining a specific behavior for specific platforms. So this can be used where it makes sense. You don't have to do that for every code you write. So now that we have looked at some of the basics of what you can do with Haxe, I will try to speak about what is it to write a new programming language, and what are the reasons for that. Basically, you write it because it's a new mix. It's something that is not really available somewhere. So you want to. I've been just doing maybe learning 7 or a little more than that, maybe 10 programming languages, and I've been using several of them for several years. So when you get experiences with several programming languages, which I'm sure most of you have, you start being able to compare things and say, okay, I like this stuff, and I don't like this, but I like this stuff in this language. So, but if you put all the things you like of the different programming language you are using together, you end up with something that is not really working. So designing a programming language is the ability to make choice and to see what kind of, to experiment with it, to just putting something inside and being able to remove it at some time because you feel that it doesn't work well together. So basically what I did for a few years. And what you want to write the programming language is because you can't do it at the beginning. This is some kind of goal. I mean, being able to write a programming language is not an easy thing, but the thing that when you start, you can't really do that, and you start, but you try. At least you say, I will try. And in the end, you can do it. I could do it. So basically, it's just, it takes time to learn, but when you can do it, it's a lot of fun. It's a lot of fun being able to do these kind of things. And also, that's the way evolution works. I mean, if people were always satisfied with the programming language they are using, I mean, we will be back 10 years ago or more. I mean, there is, the way evolution works is some people are not very satisfied or they want to just bring new things. And in the end, it's better for the user because they are the ones that are able to choose what suits them. So that's my reason for doing some programming language. So I will a bit past the time I was thinking. So I wanted to show you some code of Haxe, but we are a bit off the delay, so I will just go on and maybe you can have a look later. So I want to add a few words about Neko virtual machine. Neko virtual machine is a small virtual machine written in C. It has a standard library, but you can add additional APIs to it by just doing some additional C code. So, for example, people in the community, they wrote SSL library, OpenGL library, SDL library, and they're making a lot of new stuff with it. Because with Neko, you can write several things. You can use it everywhere. I told you can use from command line, like we did some tests with a web server. You can use to write a Windows application also. Not only running on Windows, but windowing a Windows application, which run some games or some things. And basically any kind of application, also server application. I will show that later. So basically, you can extend the virtual machine to bind it with an existing C API or CDLL. And then you can use these functionalities from Haxe directly. And it's pretty easy to, not so much complicated to do. So when you do that, you can just put in more possibilities in the virtual machine and more possibilities to access the API in the language. So that's nice. For an example of the kind of things you can do, which is not really exactly web-related, but it's not for the web, but it's a server also, which is written in Haxe, which is a server Haxe Video. So basically, Haxe Video is a streaming server for the FLV file format, which is a Flash video file format. So this is a Flash video file format, a streaming server. So, and it's entirely written in Haxe code. So basically here you have the client logical. So if you look client server logic, so it's 30 kilobytes Yeah, maybe you can see it, but it's only 4 files and 30 kilobytes of code. So it's all the jolly calls that enable the client to connect to a server, and that, depending on the commands, will reply to it. And here we have also like 20 kilobytes of code for the different formats, which is RTMP, which is a format used to stream the FLV over the network. So, and that's all. I mean, you have a whole streaming server for FLV in around 50 kilobytes of code. So of course, it is so very small because it doesn't have an UI, right? So it's just command line application. I'm sure if it had an UI, it would be a lot more bigger, but well. So we're just starting the server this way. It's running on localhost on this default port, which is the default video port for Flash. And I will start also the client. So the client also is written in Haxe. It's part of the Xvideo distribution. I didn't count as part of the sources, but basically it's just a small client that will enable you to do several actions. So you can, for example, place a test video. I don't know if I have sound. Maybe I can connect it. Why does it go on? This is a very funny Japanese video. I need to get sound. Is it there? No, this is microphone. My headphones there. Okay. Okay. Well, that's playing with the hair and like things. That's quite funny. So basically, what we are doing there is just playing a video which is on the server, so we can see the different commands that are occurring on the server there. So we are connecting, then we are create stream, then we are playing the test.flv, which is what the things the server, the client is doing. So when we click, it's just pause. Okay. So you can see the pause command that is occurring, and we have these timestamps which say at which timestamp we are pausing. And when we just click again, we are just toggling the pause one more time. So of course, look at the Mexican guy running us so crazy. And of course, if you are closing the server, the video stops, right? So it's streaming, right? So you have a small buffer, but the server can't control all the buffer is working and everything. So I will restart the server. And what you can do as well, I can't demonstrate it because I don't have a webcam, but you can record the webcam and microphone that is shared by the Flash player, and it can record a FLV. So when you click there, it will just say, webcam not found. That's sad, but you can record yourself, and it will store FLV, and you can share the webcam as a live streaming to other people connecting to the server. So you can build conferences, web conferences with a webcam and microphone with this technology. I mean, that would be a good idea. And I will show you, for example, this is the kind of video I built when I released the Xvideo server. So I built that myself with my own webcam. So that's a pretty cheap video. I didn't have so much budget, and this is pretty difficult. It's pretty difficult to do. And you can look at that. It's just slowing, and so I mean, it's just fighting against the evil proprietary web video empire or something. Well, you can see the complete text on the the video, well, yeah. The Destar is a video streaming server costing enough money to destroy an entire project. So, well, that's it. So you can record. So this is the kind of technology that's written in Haxe. You can just record the video and just stream it to the client. So it's pretty neat. So let's back to the slide. So this is some examples that Neko is not only about writing web application. You can use it also for writing servers and a lot of different things. So let's have a look about Haxe remoting. Now you have all these platforms together. How do you make them talk together? because we have solved one part of the problem, which is to simplify the whole thing by having the same programming language. But how do you make things communicate together? The idea is to use some kind of X-remoting, which is called a standard API that works, that is pretty much the same on all platforms, and that connects things together. So for example, you can connect Flash and JavaScript together. You can connect in the two ways. You can connect JavaScript to the web server. You can connect JavaScript to a real-time server. You can connect Flash to a real-time server, and you can connect servers between them or Flash and between other Flash. So all these kind of remoting connections are possible. So you have actually one single API. Actually, you have two versions of it. One which is for synchronized calls, one which is for asynchronized calls, because it's based on RPC, which is a remote procedure call. So basically what you are doing is just sharing some object for a connection, and then people connect, and they can call a method on your objects, and they get the response. And it's based on an open protocol, which is using the serialization format, which is open. So, and it's optimized for interoperability, so it's not binary, just text format that you can use to serialize values and arguments and method names when you are making some calls. And then you get back the value, which is also serialized, and well, that's the way it works. So it's a good way to just make everything just talk together transparently. So, how much time we have? 15 minutes, right? Okay, perfect. So, I want to take a time to talk a little bit about X philosophy, because we've been talking a lot about technology, but I think that when you are writing software, it's not only about technology, it's also a bit about the ideas behind it and the way you want to change the things. So the state of the web today is that there is a lot of concurrent technologies and platforms. There is closed source one and open source one. In particular, like the Flash player is closed sourced, and you have this browser war going between Firefox and Internet Explorer. And well, I don't really know what will be the web in 10 years, because it doesn't have so much history right now. I mean, the history is pretty short. So when the history is pretty short, and it's evolving so fast, you don't really know what will be the web in 10 years. And I don't think that anybody knows what will be the web in 10 years. So there is a lot of possible evolutions in the future. One of the things to show that what I'm talking about is that I will show you an example of which is XMatrix 4. XMatrix 4 is something that's being talked at the ECMA consortium, which is a group of trying to make standardized documents. And it's actually the name for the code name for JavaScript 2. So there is a lot of different companies involved in this design of these new languages. In particular, there is Mozilla, there is Adobe, and there is Microsoft. I mean, that's maybe the three main contributors. There is also like Opera, Apple, But the three main ones talking about this technology are Mozilla, Adobe, and Microsoft. And well, let's have a look little for a moment at what the stakes are and how things are just being done. So if I'm a bit criticized, I will say that if I want to be a bit caricaturing each proponent, that Mozilla has a lot of time invest in JavaScript. They are doing a lot of things in JavaScript for their own applications. But well, I can understand that they're getting a little bit tired of current JavaScript because it's not very fun to write JavaScript. So what they are trying to do, or what they want to do, is just to push for a new standard with a new programming language called XMatrix 4, and which is have more features and a lot of more things inside it that will suit their needs for developing application for the web. I mean, that's normal. Everybody is doing that. And then you have Adobe. And Adobe is really siding with Mozilla on this to push for XMatrix 4. Why Adobe is just acting this way is not out of interest. It's because for years, Adobe has been, which they now own the Flash, because before it was Macromedia, now it's Adobe. They have been seen as making some proprietary technology with Flash. And they want to say, oh, we are not making anything proprietary. We are just using XMatrix 4, which is an open standard. Well, here on the XMatrix 4 board, we are deciding anything about it. we are providing the virtual machine for it, but we are open. And while this kind of this is a move to say we are not closed, we are open. But in the end, they are sending you tools because the tools to develop Flash is not entirely free. So, and Microsoft on this also is against x84. And I mean, if I was Microsoft, I would be against. Because you are, if you have invested a lot of money and a lot of time into developing your own technologies, like which is C#, .NET, and all the Silverlight stuff, you don't want a new standard to come up and just remove everything you've been investing. So Microsoft will never include JavaScript 2 into Internet Explorer. And Internet Explorer is still, sadly, the most used browser on the internet. And we can't do anything about this because as developers, we can't really control what installed on the virtual machine. Well, some people control that, but they are called virus writers, right? They just put something on your virtual machine on your machine without you wanting to do that. But right now, there's the three companies that control the web and the way it's displayed to the users. They are Mozilla, Microsoft, and Adobe. That's the way it is right now. And in this whole things, nobody is really asking what developer wants. I mean, they just trying to solve their own problems, which is nice, but there is not really a place to talk about this openly and to decide what should be done or not. So, I mean, that's a problem. I mean, I'm just posing a problem there about how the web should evolve and how things should be decided by the community. Because I think the web is a big community and which right now is being driven by a few companies that are just acting in their own interest. So my point of view about Haxe about this is kind of freedom, because whatever in general, when you are just using a programming language, it's come up with its own platform, with its own virtual machine. PHP has its own virtual machine, Python has its own virtual machine, Java has its own virtual machine, .NET has C# has its own virtual machine. So usually when you get a language, you get all the runtime with it, and you cannot really run it on other platforms as well, because what's it? And because usually it's tied together. So some people right now, it's quite popular to be able to run other programming language on other virtual machines. For example, running Python on .NET, on running Ruby on Java, or other kinds of things are being done this way. But it's not, the language have not been designed for that. And it's very, very difficult to do that. And in the end, it doesn't really work exactly the same. So it's not a very good idea. If you want to do that, you have to do it from the beginning by designing a language that runs on all the platforms that it means to be run on different platforms, and by making clear separation between what is part of the language and that it works the same, and what is left to the platform and which will be like abstract and will depend on the runtime. And that's what Haxe is doing. Is defining some kind of which is the same on all the platforms, but is leaving space for each platform to have its own properties. So it's some kind of freedom for the future, because whatever the next platform, the next big thing will be, then Haxe will be able to support it. And its next thing, I don't know, is maybe Silverlight will just take off, and I'm not sure it will, but I hope it will not. But well, if Silverlight takes off and just gets the next big thing, then Haxe will just compile to .NET, and it will just, well, it will work. So, well, that's my point of view about the thing, so you don't have to agree with me, but we will see that. So for some resources, you can do x.org, which is the X website. There is a blog when you can have some posts about what's occurring in the X community. There is a lead.x.org, which is a repository of libraries. There is a command line tool that you can use to download libraries and upgrade them, or like apt-get or these kind of things, package manager. And to finish, I want to have a word that Haxe is a really great community. There is all these different people doing great stuff with Haxe, with the language. They are writing libraries, they are writing tools, they are writing a lot of different things. And it's really rare to in a programming language community to see all these people coming from different points. They are coming from some are really coming from the web. They are coming from JavaScript. Some are coming from Flash. Some are coming from server development. And they all come together, and they are just trying to make cool things with the language. And it's very great to have all these different people acting together in the same community. So I would like to thank you. And I hope that was clear enough in explaining what is X and what it is not, because there is a lot of things to explain, and it's not really easy to just put it together into one presentation. And I think we'll have time for some questions. So just raise your hand if you want to ask some question, and we'll just...
Hello, the Nico VM exists for the BSDs, or at least for FreeBSD. Is there any project on the way to port Haxe to the BSDs?
Yeah, so Nico VM runner of BSD. I think there is I think someone submitted me a patch. I need to apply it for it to work perfectly. But Nico VM is written in NCC. So basically, it compiles on all the platforms that have a C compiler. It doesn't need so much tweaks. Voilà, that's it. And for Haxe, Haxe is written in OCaml. The X compiler is written in OCaml. So and OCaml is widely supported on a lot of platforms as well, and it's available on BSD as well. So you can compile the source from BSD without any problem.
I have a pretty specific question. As a JavaScript developer, you usually don't tend to like writing JavaScript. You use libraries. Does Haxe provide support for libraries like jQuery or Prototype or other stuff?
Can you just rephrase maybe?
Does Haxe provide support for JavaScript libraries like jQuery and?
So yeah, what you can do basically when you want to reuse some code which is in Flash, either in Flash or in JavaScript, you can write some kind of external interfaces. So it just, you say this is an external classes, and you just declare all the methods, and then you can create new instance of it and just call the method, and it will just work transparently. So, and you can put some types. So if the library you are using is typed as well typed, you will get all the typing from Haxe, and you can use these libraries as well. There is no currently wrap libraries, but you can do that, and it's pretty easy. Other questions? Yeah.
You mentioned standard serialization format for remote procedure calls. Would you say that it's feasible to call Haxe from other languages? If that exists, can you make some examples? Yeah,
it's very easy. Some people write, for example, they are using Haxe with an Erlang server, and they wrote some kind of just a small serialization. It's just one class. It's not very big. I already wrote it 3 times. So it's just you can easily port it to other languages, and you don't have to support all the things because there is, for example, classes. You can send classes between the two, but maybe you don't want to do that in your programming language, and you just want to send data structures. So well, it works pretty easily.
So we saw that you showed us on Windows, and it's quite a nice editor for Haxe. So what about support for editors on Linux and other operating systems?
Support for Linux, you mean?
Yeah.
But I mean, everything works on Linux, so...
No, the editor.
The
editor.
The editor.
With auto-completion and the debugger,
yeah.
And then, I mean,
okay, so for the editor, I'm quite already busy with all these things. So I didn't invest much time into writing an idea. But what I did is just to all the completion stuff is directly integrated in the compiler. So if you want to support Haxe for your own editor, I have some guys at my company that have been integrating into VI. So you have the whole compilation thing running into VI. But you can do it pretty much for any kind of editor you want. It's pretty easy to do. You just add syntax selecting. I mean, it's just configuration file. And for completion, basically, you are just calling the compiler and return you some kind of XML that you just use it to parse to display completion. So there is nothing very difficult to do, and you can support any kind of IDE that you want. Any question? Yes?
Yes. I have 2 questions. First one is does Haxe support JavaScript 2.0 as a source language?
Yeah, it's using JavaScript 1.3, which is the current one running on all the web browsers. And if JavaScript 2 take off and becomes the next, big thing, then we generate JavaScript 2, and there is no reason for that.
I was meaning as a source language, because or is it very...
At the source level, it generates JavaScript, just JavaScript that can be run on current web browsers, which is JavaScript 1.3. I think
okay.
I am.
And the second question is it possible, for example, to see Neko as a VM for Python language? So to compile the Python language as a Neko binary byte.
Yeah, Neko has been...
And if you see that will have some better performance or something than the native Python interpreter.
Neko has been designed to run lots of different kind of programming language. There is currently three that are running on top of Neko. There is a Neko, which is kind of scripting language. There is a Neko ML, which is kind of OCaml for Neko. And there is Haxe. You can put other language that run on top of Neko. But, well, you can do that. But after, it depends on the language. Usually, Neko is dynamic is not enough to be able to get good performances and to be able to do it support any kind of programming language. But Python is pretty dynamic language. It has all this overriding stuff. So I guess you could write a Python to Neko compiler, and you should get at least you should get the benefits of the just in time, and that makes sense. But yeah, well, other questions?
When did you start to work on Haxe, and when did it become usable?
I started working a little more on Haxe. Before that, I wrote maybe 2 or 3 compilers, a little more maybe, and several programming language. And I started really, I had this programming language called Motion Types we are using in my company for 3 years before Haxe. And I did a clean rewrite, and that became Haxe. And so I started working on Haxe, redesigning the language and just writing the type system and everything. It was in the end of 2005. And the 1.0 release was released in the, I will say, I think it's beginning of summer 2006. So that's a bit more than 1 year and a half ago.
First of all, thanks for your presentation. A question, is Haxe already used in large-scale products, and how does it scale in the backend? For example, when you use it as a server, is it really scalable, and how does it perform, for example, compared to Java or Ruby on Rails projects?
Well, Ruby is pretty slow. So I would say it outperforms Ruby and it outperforms PHP. It should be on par with Lua, which is already pretty fast. It depends what we are doing, right? So if you are doing a lot of computing, on your programming language, then it will work very well. It will not be like Java, because Java is completely typed and running in. They are very good, invest a lot of time into making a virtual machine that runs very well. But at the same time, Java is very consuming in terms of memory. So Neko is, I think, between the two. It's between, you have Ruby, which is less, or PHP maybe, which is less memory, but a lot of CPU, and you have Java, which is a lot of memory, but less CPU. And I would say it's between the two. So you get a good trade-off between speed and memory, which is important for web development. And we have some websites which are the most big website we have. It has something like 116,000 daily users, and it runs on maybe 1 or 2 servers or something. So it's just not one server for the database and 1 server or 1 or 2 servers for the web. So it's scale.
So what about the MTest compiler? You stopped the development because of X compiler, or?
So yeah, MTask development. MTask is a H Transcript 2 compiler I wrote before Haxe. And yes, it's not. It's not that I stopped the development. That's just the compiler is complete. There is no bugs, and I can't extend the language because it's not. I'm not the one writing Haxe Transcript 2. language, and ActionC2 language is not going anywhere now because it's being replaced by ActionC3. So basically, MTask is done. That's its current status. It's finished. After there is some bugs, well. So if you have more questions, you can just come to me. I will just stay around because I think we are out of time. So I would like to thank you one more time for listening.